A fire outbreak can have devastating consequences: property damage, loss of home or office, lengthy insurance claims, thousands in cleanup bills, and in the most tragic circumstances, even the loss of life. For 100 years, the most common protection for land-based buildings against such an occurrence has been the installation of conventional, low-pressure water spray or sprinkler systems. These systems fight fire efficiently, but water damage is often greater than the direct fire damage. High fog, high pressure water mist fire protection systems have been fighting fires since 1991 on land and sea, aiming to minimise fire, smoke and water damage in case of fire. High fog systems have utilised water more effectively than the conventional sprinkler or spray systems by combining the firefighting properties of water with penetrative qualities of gas. The end result is an efficient, safe and effective system that minimises water damage. High fog utilises high pressure to create a fine water mist, suppressing and controlling the fire efficiently. The small droplet size enables the room temperature to cool at a faster rate than a traditional sprinkler system, and the high number of droplets also blocks the spread of radiant heat. It is also suitable for combating liquid fires. High fog systems are used across the globe in a wide variety of land-based and marine applications. Thousands of full-scale fire tests have proven their effectiveness, and the systems are regulated to meet local industry standards, including compliance with AS 4587, AS 2118, AS 1851 and the BCA. The systems are also internationally approved by FM and VDS, are compliant with IMO regulations and have over 100 type approvals for various applications. Not only is the system highly effective, but it is also versatile enough for a range of applications, all of them based on high fog technology, utilising high fog components. These include sprinklers and spray heads, section valves, high pressure pumps, piping, and a range of standard and special fittings to aid installation. Application-specific high fog systems have been proven to be successful in protecting machinery spaces, turbine enclosures, underground railways, large data centres, hotels, offices and heritage buildings, hospitals, offshore platforms, and vessels throughout the world. High fog systems are lightweight, easy to install, require minimal space, and are safe for people, property, and the environment. Let's take a closer look at the individual components that form this unique system. The sprinklers are made from high-quality brass that is nickel or chrome plated, although there are other finishes available. You can see here some of the high fog components used in a typical installation, including the distribution block, which aids efficient connection of the small bore tubing, and the patented sprinkler nozzle, showing the sprinkler body, micro nozzles, and heat-sensitive glass bulb. When the temperature in a room begins to rise from the effect of a fire, the heat-sensitive bulbs break, which releases the sprinkler's spool valve, and the high-pressure water is then released through the sprinkler jets as a fine droplet mist. The pump unit generates a high-pressure water supply, which enables the mist to be created at the patented nozzle, and can be scaled to fit into most environments and is easily concealed. Be it gas-driven or electric-powered, there is a high fog system to suit most applications, no matter what their configuration. The best way to understand how the high fog system works is to see it in action. Take a look at the following demonstrations to see just how effective it is. This demonstration was the result of a joint program conducted by Kitty Australia, the high fog land-based distributor, and the Marioff Corporation of Finland, and was conducted in February 2010 and simulates a typical hotel room fire. There is a high fog 2000 series sprinkler nozzle mounted in the centre of the ceiling, which is supplied by a high fog modular sprinkler pump unit once the standby pressure falls below its control threshold. The room is filled with furniture you would normally find in a hotel room: a mattress, side table, chair, and small table. The source of the fire is set to simulate a smouldering cigarette or cigar, although for the purposes of the demonstration, some accelerant was added. Here you see the fire begin to burn, and once the temperature inside the room is exceeded, the heat-sensitive bulb breaks, triggering the high-pressure water mist. within 5 minutes, the fire has been suppressed significantly and brought under control, and any remaining fire is extinguished using a high fog hose reel. According to NFPA 750, the US standard for water mist, the system is designed to operate minimum 30 minutes. However, the system can operate as long as there is water and a power source available. Now that the fire is out, you can see the room suffered minimal smoke or water damage. The high fog system is also effective when combating liquid fires, as you'll see in this demonstration. Here's a firefighter battling a blaze fueled by an ethanol, petrol, and diesel combination, simulating a pool fire. Again, when the system is triggered, a fine mist envelops the flames, quickly lowering the temperature and suppressing the fire using a minimal amount of water. High fog systems are already installed in land-based buildings throughout the world and are an innovative new solution to firefighting systems. They are easy to install and can be readily retrofitted in most buildings. By combining the extinguishing properties of water with penetrative qualities of gas, high fog systems can be an effective alternative to conventional sprinkler or spray systems. The end result is a fast and effective system that minimises water damage without endangering people or the environment.